Hello students, in our previous class we have discussed about group 15 elements, and in today's class we are going to discuss about group 16 elements which are known as chalcogens. So they are also known as oxygen family elements. So in this group 16 elements there are 5 elements are there: oxygen, sulfur, selenium, tellurium and polonium. Okay, these are the 5 elements which are present in chalcogen family or in oxygen family. The occurrence of these elements, oxygen, okay, it forms 46.6% by mass of Earth's crust. Okay, ಹೆಚ್ಚಿನ ಒಂದು almost 46.6% ಯಾವುದು Earth ನ crust ಅಲ್ಲಿ ಇರುವಂತದ್ದು ಯಾವುದು ಆಕ್ಸಿಜನ್ ಅಥವಾ ಅದರ ಕೆಲವೊಂದು ಕಾಂಪೌಂಡ್ಸ್ ಗಳು ಬೇರೆ ಬೇರೆ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರ್ತದೆ. Dry air contains 20.946% of oxygen by volume. So usually ನಾವು ಅದನ್ನು 20.1% ಅಂತ ಬರೀತೇವೆ. ಓಕೆ, ಇದು ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಸಲ್ಫರ್, a very small amount of sulfur is present in Earth's crust. ಅರ್ಥ ಆಯ್ತಾ? ತುಂಬಾ ಕಡಿಮೆ ಇರ್ತದೆ. Traces of sulfur is present. So ಇದನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಇದನ್ನು 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. They may ask you to write the formula of various forms of sulfur. Okay, sources of sulfur ನಲ್ಲಿ ಯಾವುದೆಲ್ಲ ಇದೆ? gypsum, ಇದರ ಫಾರ್ಮುಲಾ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. Okay, write the formula of gypsum. Calcium sulfate, hydrated calcium sulfate, CaSO4.2H2O. Next, Epsom salt. ಇದು ಕೂಡ ಅಷ್ಟೇ 1 ಮಾರ್ಕಿಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. MgSO4.7H2O. Epsom salt, MgSO4.7H2O. ಇದನ್ನು ಕೂಡ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. Next one is barite. So ಇದು sulfates. ಈ 3 ಏನಿದೆ ನೋಡಿ, ಇದು sources of sulfur. They are in the form of sulfur is in the form of sulfate. Next, along with that, sulfur is also present in the form of sulfides. So ಇದು ಕೂಡ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. ಯಾವುದು? ಗ್ಯಾಲೆನಾ, PbS, ಗ್ಯಾಲೆನಾ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. ಜಿಂಕ್ ಬ್ಲೆಂಡ್, ಜಿಂಕ್ ಸಲ್ಫೈಡ್, ಜಿಂಕ್ ಬ್ಲೆಂಡ್ ಅಂದ್ರೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಕಾಪರ್ ಪೈರೈಟ್ಸ್. ಸೊ ಇದು ಕೂಡ ಅಷ್ಟೇ, ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಫಾರ್ಮುಲಾ ಬರಲಿ ಕೇಳ್ತಾರೆ. ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಕಾಪರ್ ಪೈರೈಟ್ ಎಂದ್ರೇನು? CuFeS2. ದಿಸ್ ಇಸ್ ದ ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಕಾಪರ್ ಪೈರೈಟ್. So composition of gypsum is calcium sulfate .2H2O. Composition of Epsom salt is MgSO4.7H2O. ಇದನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Next, selenium and tellurium are also found as they are selenides and tellurides. Sulfides ಇದ್ದ ಹಾಗೆ ಇವುಗಳು selenides ಮತ್ತೆ tellurides ಅಲ್ಲಿ ಇರ್ತವೆ, but very rarely found. ತುಂಬಾ ಕಡಿಮೆ ಸಿಗ್ತದೆ. Polonium, so it is obtained as a decay product of thorium and uranium. ಥೋರಿಯಂ ಮತ್ತು ಯುರೇನಿಯಂನ ಡಿಕೆ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಸಿಗ್ತದೆ. ಸೊ ಇಟ್ಸ್ ರೇಡಿಯೋ ಆಕ್ಟಿವ್. ಅಂಡರ್ಸ್ಟೂಡ್? ಎಸ್. ನೆಕ್ಸ್ಟ್, ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ಗ್ರೂಪ್ 16 ಎಲಿಮೆಂಟ್ಸ್. ದ ಜನರಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಇಟ್ಸ್ NS2 NP4. ಓಕೆ, ನಾವು ಇಲ್ಲಿಂದ ಕಂಟಿನ್ಯೂ ಗ್ರೂಪ್ 15 ಇಂದ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೇವೆ. NS2 NP3 ಇಂದ. ಓಕೆ, 13 NS2 NP1, 14 NS2 NP2. ಇದೆಲ್ಲ ಕಾರ್ಬನ್ ಎಲ್ಲ ಬರ್ತದೆ. ಸೊ ಇದು ನೈಟ್ರೋಜನ್ ಫ್ಯಾಮಿಲಿದು, ಆಕ್ಸಿಜನ್ ಅನ್ನೋ ಚಾಲ್ಕೋಜನ್ ಫ್ಯಾಮಿಲಿ. ಅರ್ಥ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, ಅಟಾಮಿಕ್ ಅಂಡ್ ಅಯೋನಿಕ್ ರೇಡಿಯೈ. ದ ವೇರಿಯೇಷನ್ ಆಫ್ ಅಟಾಮಿಕ್ ಅಂಡ್ ಅಯೋನಿಕ್ ರೇಡಿಯೈ, ಹೌ ಇಟ್ ವೇರೀಸ್. ಅಟಾಮಿಕ್ ರೇಡಿಯೈ ಮತ್ತು ಅಯೋನಿಕ್ ರೇಡಿಯೈ ಹೇಗಾಗ್ತದೆ? ಡೌನ್ ದಿ ಗ್ರೂಪ್ ಇಟ್ ಆಲ್ವೇಸ್ ಇನ್ಕ್ರೀಸಸ್ ಆಸ್ ಯೂಶುವಲ್ ಟ್ರೆಂಡ್. ದರ್ ಇಸ್ ನೋ ಎಕ್ಸೆಪ್ಷನ್, ನಥಿಂಗ್ ಟು ವರಿ ಅಬೌಟ್ ಇಟ್. ಅಟಾಮಿಕ್ ಅಂಡ್ ಅಯೋನಿಕ್ ರೇಡಿಯೈ increases down the group due to the addition of number of shells. Next one, ionization enthalpy. So here this is very important. It has some or certain exceptions. So what happens to the ionization enthalpy down the group? Ionization enthalpy down the group decreases, it decreases, not increases. It decreases. Nimge gottide, as size increases, effective nuclear charge decreases. So ionization enthalpy down the group decreases, along the period increases. You know the trend. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಏನಾಗ್ತದೆ? ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಓಕೆ, ಇಟ್ ಇನ್ಕ್ರೀಸಸ್. ಬಟ್ ಇಲ್ಲಿ ಒಂದು ಎಕ್ಸೆಪ್ಷನ್ ಇದೆ. ವಾಟ್ ಇಸ್ ದಟ್ ಎಕ್ಸೆಪ್ಷನ್? ಲೆಟ್ಸ್ ಸಿ ದ ಎಕ್ಸೆಪ್ಷನ್. ಆ ಎಕ್ಸೆಪ್ಷನ್ ಏನು ಅಂತ ನೋಡುವ. Ionization enthalpy of group 16 elements are lower than that of group 15 due to half-filled p orbitals. ನೋಡಿ, group 13, 14, 15, 16, 17, 18 ಹೀಗೆ ಹೋದ ಹಾಗೆ ರೆಗ್ಯುಲರ್ ಟ್ರೆಂಡ್ ಏನು? What we observe, ರೆಗ್ಯುಲರ್ ಆಗಿ ನಾವೇನು ಹೇಳ್ತೇವೆ? as size decreases, ionization enthalpy increases ಅಂತ ಹೇಳ್ತೇವೆ. But there is exception. Okay, 16 ಇದು ಆಕ್ಚುಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕಿತ್ತು. 15 ಗಿಂತ 16 ಇದು ಜಾಸ್ತಿ ಇರಬೇಕು. ಇಟ್ಸ್ ಸಪೋಸ್ ಟು ಹ್ಯಾವ್ ಮೋರ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ than group 15. Is it correct? Yes, that is due to the decrease in size. But there is an exception. Lower ionization enthalpy than group 15 due to half-filled p orbitals. See, group 15 elements, they have exceptionally high ionization enthalpy because it has ns2 np3 configuration. ns2 np3. That means you have to remove an electron from a most stable half-filled p orbital. Is it correct? So this requires more energy than the removing electron from np4. Okay, np4 in the electrons ತೆಗೆಯುವಂತದ್ದು easy because this is not the half filled configuration. Understood? So ಈ reason correct ಆಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. This will be asked for 1 mark. The ionization enthalpy of group 16 elements are lower than that of group 15 element because in group 15 element we have half filled orbitals. Removal of electron from extra stable half filled orbital is difficult. Okay, in case of P as well as in case of D, same thing happens. Is it clear? Yes. The next one is electron gain enthalpy. What is electron gain enthalpy? It's energy released when an electron is added to outermost orbital. Is it correct? So it defines the tendency of an atom to gain the electron. So you'll notice oxygen is most electronegative after fluorine. Due to the compact nature of oxygen, it has less negative electron gain enthalpy than sulfur. Electron gain enthalpy ಏನಾಗ್ತದೆ down the group. So down the group ಏನಾಗ್ತದೆ electron gain enthalpy ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಈಗ oxygen, it has less negative electron gain enthalpy of oxygen is less negative than sulfur. Usually ಏನಾಗಬೇಕಿತ್ತು oxygen ಇಂದ polonium ಗೆ electron gain enthalpy decrease ಆಗ್ತಾ ಬರಬೇಕಿತ್ತು. As the size decreases, electron gain enthalpy increases. Okay, so we expect more electron gain enthalpy for oxygen, but due to its smaller size, compact size, what happens in the case of fluorine also same thing happens. Fluorine alli kuda hage agtade, oxygen alli kuda hage agtade due to the repulsion. So due to the electronic repulsion, so oxygen is not ready to accept an electron. Ashtu sulabhadalli adu electron annu takoludilla. It cannot gain electrons so easily when compared to sulfur. Sulfur takes electrons easily than what? That of oxygen. So reason enu? Compact nature of oxygen. Due to compact nature of oxygen, it has less negative electron gain enthalpy than sulfur. Artha aithalva? So idu actually trend ge exception. It's an exception. You remember this. Next, electronegativity. You know what happens to electronegativity down the group? Electronegativity decreases down the group as size increases, electronegativity decreases. So here that indicates metallic character increases from oxygen to polonium. Metallic character ಏನಾಗ್ತಾ ಹೋಗ್ತದೆ? So metallic character ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಆಕ್ಸಿಜನ್ ಇಂದ ಪೊಲೋನಿಯಂಗೆ. ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಪಾಸಿಟಿವಿಟಿ, ಟೆಂಡೆನ್ಸಿ ಆಫ್ ಲೂಸಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಸರಿಯಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಥಿಂಗ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದೀಸ್ ಮೆಟಲ್ಸ್, elements, chalcogens. Among 5 elements, oxygen and sulfur are what? Non-metals. So ಇವೆರಡು non-metals ಗಳು. Selenium and tellurium are metalloids. Polonium is a metal, but it is a radioactive one. It has only 13.8 days of half-life. Decay ಆಗ್ತದೆ, ಇದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. And usually they exhibit allotropy like some of the group 15 elements. So they exist in various physical forms. Next, boiling point and melting point increases with increase in atomic number. Regular trend adu. As in the case of group 15 also you studied the same thing. As size increases, as atomic number increases, boiling point and melting point also increases. Mass ಜಾಸ್ತಿ ಆದಾಗೆ ಏನಾಗುತ್ತೆ? Both boiling and melting point also increases. Here, oxygen and sulfur have large difference in the melting and boiling point due to the atomicity. So this is an exception. This is very, very important. Remember, oxygen and sulfur have large difference. The melting and boiling point of oxygen is very small when compared to sulfur. Oxygen is nearly having 55 Kelvin of boiling point. Sulfur is having nearly 393 Kelvin of boiling point. So yeah, here what is the reason? Oxygen and sulfur have large difference in their melting and boiling point is due to the atomicity. So oxygen is a diatomic. Okay, it is diatomic molecule. But sulfur is a polyatomic. It's represented as S8. It's allotropy of sulfur. S8, polyatomic molecule. As atomicity increases, both boiling and melting point also increases. You remember this. So why oxygen has less boiling and melting point than sulfur? It is due to the large difference in their atomicity. Large difference, not a regular difference. Remember, it's a large difference, not a regular difference. It's due to difference in atomicity. Understood? Yes. The next is about the chemical properties. The chemical property of an element is because of its electrons. Correct alla? The electron mele depend agirtade. So let us study with the oxidation state first. Here these elements exhibit variable oxidation states like -2, +2, +4, +6. The smaller, most electronegative oxygen only shows negative oxidation states like -2. Okay, stability of -2 oxidation state decreases down the group. Stability of -2 oxidation state decreases down the group as electronegativity decreases. Oxygen ge ಒಂದು ಮಾತ್ರ capacity ಇರ್ತದೆ. ಏನು capacity? To accept the electrons. Polonium hardly shows +2 oxidation state. Sorry, -2 oxidation state. Okay, -2 oxidation state down the group decrease ಆಗ್ತಾ ಬರ್ತದೆ. Next, in OF2 only, oxygen shows +2 oxidation state. 1 mark. This is important. Remember, they will ask it for 1 mark. So, in the presence of fluorine only, oxygen shows +2 oxidation state. Here, +4 and +6 are more common in these elements. Sulfur, selenium, tellurium shows +4 with oxygen and +6 with fluorine. Okay, smaller fluorine, in the presence of smaller fluorine atoms, they show +6 oxidation state. Stability of +6 decreases down the group, +4 increases down the group due to inert pair effect. So, so it removal of 2 s2 electrons, ns2 electron becomes difficult. Okay, they remain intact. So, due to that inert pair effect, +4 oxidation state increases what the stability of +4 oxidation state increases down the group, +6 decreases down the group. Remember, this is about the oxidation state. Continuing with the chemical properties, anomalous behavior of oxygen. This is very important for 3 marks. They will ask why oxygen shows anomalous behavior. So oxygen shows anomalous behavior due to 3 reasons: because of small size, high electronegativity and absence of d orbitals. Understood? So it behaves anomalous when compared to the other 4 elements. ಬೇರೆ 4 elements ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ anomalous behavior ತೋರಿಸ್ತದೆ. ಯಾಕಂದ್ರೆ it differs from rest of the elements. It's smaller in size, high electronegativity. So ಇದನ್ನ ಹೇಗೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು ನೋಡಿ, H2O ಅಂತ ಫಾರ್ಮ್ ಆದ್ರೆ it forms stronger hydrogen bonding with the neighboring water molecule. So here this oxygen forms hydrogen bonding with hydrogen atom of neighboring water molecule. So this is just because of the small size and high electronegativity. In the case of H2S or H2TE, okay, we cannot expect the same type of hydrogen bonding. That's because of the difference in the electronegativity. In the cases galalli, we cannot find any type of hydrogen bonding. Only in water we can find hydrogen bonding. So the reason is because of its small size and high electronegativity. Second one, third one, absence of d orbitals. So its covalence is only 2. It's because of the unavailability of d orbital. Yakanta heltane. You look at the electronic configuration: 1s2, 2s2, 2p4. Okay, in outer shell we have only n is equal to 2. So 2d is not possible. So in that outer shell, for n equal to 2, if the value of n is 2, it is having only s and p orbital. But in the case of sulfur, what happens? 1s2, 2s2, 2p6, 3s2, 3p4, isn't it? So this is the outer electronic configuration of what? Sulfur. If n equal to 3, L can have 0, 1, 2. We have S, P, D. So it also has vacant d orbital. It's available. So that's why it can extend its covalency. Sulfur and other elements can extend their covalencies by using that available d orbital. Is it clear? But in the case of oxygen, that is not available. That's why oxygen behaves anomalously. Okay. Next, continuing with the reactions, reactivity with hydrogen. How these elements react with hydrogen? They react with hydrogen and they form the hydrides of type EH2 or H2E. Okay, like H2O, H2S, H2SC, H2E, like this. Okay, polonium is radioactive. I'm not going to discuss it. So properties. So these are acidic in nature, okay, acidic in nature, but acidic character increases down the group. So acidic character increases down the group. So what are acids? The proton donors. See, as the size of the 15 element increases, what happens? Bond enthalpy decreases. So as bond enthalpy decreases, we can easily break EH bonds, okay. EH bonds can be easily broken here. As you move down the group, the bond enthalpy decreases. As you go down the group, bond enthalpy decreases, EH bond becomes weaker and weaker, so that we can easily remove it. That's why acidic character increases down the group, okay. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಎಷ್ಟು ಬೇಗ H+ ಕೊಡ್ತದೆ ಅಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಅದು. Next, thermal stability. Thermal stability decreases down the group. Again, thermal stability depends upon the bond enthalpy. As bond enthalpy decreases, thermal stability also decreases. Okay, when you heat it, easily these bonds can be broken. Easy ಆಗಿ ಬ್ರೇಕ್ ಆಗ್ತದೆ. ಸೊ ಇದು ಎರಡನೇ ಪಾಯಿಂಟ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ನೆಕ್ಸ್ಟ್ ಒನ್, all the hydrides except water possess reducing property. Water ಒಂದು ಬಿಟ್ರೆ ಮತ್ತೆ ಎಲ್ಲವೂ ಕೂಡ reducing property ಅನ್ನು ತೋರಿಸ್ತದೆ. So reducing property increases from H2S to H2TE. Okay, so metallic character ಜಾಸ್ತಿ ಆದ ಹಾಗೆ reducing character ಗಳನ್ನು ಕೂಡ ತೋರಿಸ್ತವೆ. Next, reactivity with oxygen. So these elements form the oxides of type EO2 and EO3. Dioxides ಮತ್ತೆ trioxides ಗಳನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತವೆ. So examples, O3 and SO2, they are gases. Selenium oxide is a solid. Reducing property decreases from SO2 to tellurium oxide. Okay, ಇಲ್ಲಿ reducing property decrease ಆಗ್ತಾ ಹೋಗ್ತದೆ sulfur dioxide ಇಂದ tellurium dioxide ಗೆ. So these oxides are acidic in nature. ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಕ್ವೆಶ್ಚನ್ಸ್ ಗಳು ಬರೋದಿಲ್ಲ, ಬಟ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ what type of oxides will be formed by these. ಈ ಎಲ್ಲ ಸಣ್ಣ ಸಣ್ಣ ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನು if possible you remember, otherwise it is not important, just ನಾನು ಹೇಳಿದ್ದಷ್ಟೇ. But they possess reducing property. Reducing property decreases from SO2 to TeO2. ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, they are acidic in nature. Is it clear? Yes. Next, reactivity towards halogens. With halogen, these elements form the halides of the type EX6, hexahalides, tetrahalides and dihalides are formed. Stability of halides decreases in the order. This is the word stability, decrease in the stability order. Okay, here hexafluorides, tetrafluorides, difluorides are stable. Okay, fluorides are stable, then chlorides. Least stable are iodides. Iodides of these elements are less stable. Remember, fluorides are more stable, iodides are less stable. Okay, as you move from fluoride to iodide, stability decreases. Okay, hexafluorides are more stable among these halides. Okay, sulfur hexafluoride, one of the example for hexafluoride of this SF6 is more stable. Okay, it's because of the steric reason. It's the most stable hexafluoride of this element. Hexafluorides ಗಳಲ್ಲಿ sulfur hexafluoride most stable. Next, tetrafluorides called SF4, SCF4, TF4. Okay, they undergo sp3d hybridization. Among these tetrahalides, this is a gas, liquid, and tellurium tetrafluoride is a solid. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Next, except selenium, other forms dichloride and dibromides. They are dimeric in nature. ಅಂದ್ರೆ ಡೈಫ್ಲೋರೈಡ್ಸ್ ಗಳನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತದೆ. S2F2, S2Cl2, S2Br2, Se2Cl2, Se2Br2. But this undergo decomposition. Okay, they undergo decomposition. Decomposition ಆಗ್ತದೆ. ಡಿಕಂಪೋಸ್ ಆದಾಗ ನಮಗೆ ಏನೇನು ಸಿಗ್ತದೆ? ಟೆಟ್ರಾಹ್ಯಾಲೈಡ್ಸ್ ಗಳು ಮತ್ತೆ ಮೆಟಾಲಿಕ್ ಸೆಲೆನಿಯಂ ಸಿಗ್ತದೆ, ಮೆಟಲಾಯ್ಡ್ ಸೆಲೆನಿಯಂ ಸಿಗ್ತದೆ. So this is how it gets decomposed. Is it clear? Yes. Thank you.